So we are finishing chapter 6 today. So chapter 6, the last lesson. This is day 14 if you've been keeping track of the days. These are all about area word problems. The good news is there are only 4 examples today. The bad news is that they each take a while. So get your notes out and we will start plugging away. The first one says a rectangle is 3 times as long as it is wide. If the length is increased by 6 meters and the width by 8 meters, the area is increased by 108 square meters. Find the original dimensions. A rectangle is 3 times as long as it is wide. So I am going to start by labeling one of the dimensions W. And how do you think I can label the other one? Well, if I call this one W, would I call the other one 3x? No, what would I call it? It's 3 times as long. Or sorry, 3 times as long as it is wide. So if the width is W, the length is? Yeah, 3W. Good. So one dimension is W. Since it's 3 times as long, the other dimension is 3W. Any questions on where I'm at so far? Okay. Now it says if the length is increased by 6 meters, so this guy is increased by 6 meters, and the width is increased by 8 meters, the entire area increases by 108 square meters. Find the original dimensions. So I am going to now draw a whole new rectangle. And I am just going to add those lengths. So to the 3W, I need to add 6. To the W, I need to add 8. Now, do you guys remember how to find area? Length times width. That's going to be a key here. So the area of this guy would be, whoop, I lost my arrow. The area of this guy, you just multiply these two, right? The area over here, you multiply by these two. And I know that this area should be 108 larger than this area. Everyone visualizing what's going on. Okay. So if I can find the area of this guy, I'm going to call that the original area. This stands for area of the original. If I add 108 to that, that will give me the area of the new. I want you all to write this down. This is going to be key. This is something you will see a lot. You start with one area and you do some sort of manipulation to it and you end up with another area. Well, we just talked about how to find that original area. What would we do? How would we find the original area? Don't worry about the 108. Don't worry about the bigger rectangle. How would I find the area of this rectangle? What? Length times width. So 3W times W? Okay, so I'm going to take this out. I'm going to put 3W times W in instead. Okay? To that, I'm going to add the 108. How would I find the area of this rectangle?
3W plus 6 times W.
Yeah, exactly. So I would have to multiply both of these. So do you see how everything is in terms of W? That's the first thing you want to check. If we have lengths and widths and L's and W's, if you still have some A's left in there, you're not going to be able to solve it, okay? So the original area, we replace that with these dimensions multiplied together. Then we have the increase. The new area are these dimensions multiplied together. Is everyone good? Now, that is the equation that I need to solve. Once I solve that, I can find the original dimensions. What is 3w times w? 3w squared. Whoops. Forgot the magical stuff stops popping up here. So yes, this guy is 3w squared plus 108 equals, how do I multiply two binomials? 3w times w, so 3w squared. 3w times 8, so plus 24w. 6 times w is plus 6w. 6 times 8, which equals 48. All right, I have some like terms that I'm going to collect before I start doing anything else. What is 24w plus 6w? Plus 30w plus 48. Okay. I'm going to pause here so everyone can catch up. All right, what do you think I should do next? Yeah, I'm going to collect up my w's. So when I get the w squareds together, what happens? They're gone. So right now I have 108 equals 30w plus 48. Minus the 48 from both sides. So I get 60 equals 30w. So divide by 30. So w equals what? 2. Did it ask me for the original width? No, it asked me for what? The original dimensions. So I need length and width. I have width and everything is in meters. So I'm going to put 2 meters by what? Well, how long was the original length? 3x. Well, if x or w or whatever variable you are using was 2, 3 times that is 6. There you go. And this isn't an x, this is a by. Like when you talk about a rectangle, a lot of times like length times by width or width times length doesn't really matter. If you want to use the word by instead so it doesn't look like a multiplication symbol or a variable, you can. All right. So this is a 2 meter by 6 meter rectangle. What are your questions? There's a lot going on in this. Are you ready for example 2? Kind of, not really. Well, let's do it. Okay. A rectangle is twice as long. That's going to be key. A rectangle is twice as long as it is wide. If its length is decreased by 4 feet and its width is decreased by 2 feet, its area will be decreased by 24 square feet. Find the original dimensions. So we have the same setup here. We are going to have 2 rectangles. Does anyone know the dimensions of the original rectangle? It's the first sentence. A rectangle is twice as long as it is wide. So what can I call the dimensions of the first one? W and 2W. Perfect. All right. Now, I need a smaller rectangle. The length is decreased by 4. So which one do I subtract a 4 from? The 2W. Good. And the width is decreased by 2. So how am I going to write the new width? W minus 2. Good. Now, I'm going to set up a similar equation that I did last time. Only now, what am I doing to the original area? Subtracting 24 to equal the new area. Okay? So here's my equation. Original area, or the area of the original, minus 24 gives me the area of the new. I would write that down so you know what I'm doing. All right, how will I find the area of the original? Okay, and what is the length and the width? Okay, so 2W times W. So I'm going to take this out. I'm going to put 2W times W in. The new area, what am I going to put?
W minus 2 times W minus 1.
Very good. These two multiply together. Doesn't really matter. Remember, multiplication is what we call commutative, so if you switch the orders, it doesn't matter. So I'm going to pop it up on a new slide. So here's where we're at. How do I start? 2W times W is 2W squared minus 24 equals, what is the process I'm going to do back here called? Distribute? Do you mean double distribute? Yeah, so I need to distribute the 2W first, then the negative 4. So 2W times W once again is 2W squared. 2W times a negative 2 is a minus 4W. Minus 4W again. And then a plus 8. Once again, I'll take a quick pause so you can catch up. If you're already here, go ahead and combine the like terms. On the next line, you should end up with 2W squared minus 24 equals 2W squared minus 8W plus 8. When I collect my 2W squareds, what happens? They're gone. Don't drop the minus here. I see a lot of people do that when this term drops off. They kind of forget that something goes in front of the 24. Don't be that person, okay? This is a negative 24 and a negative 8W plus 8. Okay, now what? Subtract 8, subtract 8. And divide by negative 8, divide by negative 8. Where do I end up with my W? 4, very good. So if the width is 4, what are we talking about? Feet? Well, the length was twice as long. So 8, yeah, just 4 times 2 would give me 8. And you'll probably have to look back at your original rectangle. Mine's just on the previous slide. So the answer here is 4 feet by 8 feet. You just plug it back into the original dimensions. What are your questions? Example 3, an oil painting is 10 inches longer than it is wide and is bordered on all sides by a 3-inch wide frame. If the area of the frame alone is 402 square inches. What are the dimensions of the painting? Whoa. Wow. All right. I'm going to draw me a picture. A picture of a picture. That's when you're really getting classy. All right, so 10 inches longer than it is wide. So what is one of my dimensions going to be? 10W would be 10 times as wide. W plus 10. Yes, if it was 10 times, you got a times, but 10 inches longer is a plus. So we're going to have W and W plus 10. Now that's the actual painting. But what else is going on in this setup? What does a border look like? Yeah, it's a bigger rectangle outside of that rectangle. So draw another rectangle. Previously we were putting them separate, but these are right on top of each other, okay? You don't put a frame like next to a picture. You put it around the picture. And how big is this guy? 3 inches on every side. So plus 3, plus 3, plus 3, and plus 3. Now, if you add 3 twice, what are you really adding? Because if you look here, we add 3 to the W plus 10, and then we add 3 again. You know what I'm saying? So just keep that in mind as well. Okay? So that's where these plus 6s come from. For the width, we added 3 and 3 to the W, so W plus 6. Up here to the W plus 10, plus 3 is W plus 16. And then just like previously, we're going to write an equation just in terms of area. So if I take the area of this rectangle and I add the area of the green part, that would give me the area of the whole thing. What? So the plus 6 is because you have to add 3 twice. Each of these is a 3. 3 inches here, 3 inches here, 3 inches here. So if this length is W, this one would be 3 and W and 3. So W plus 3 is W plus 6. Same thing here. We have 3, W plus 10 plus 3. So 3 plus 10 plus 3 is 16. Okay. Now, which one of these areas can I find based on the expressions that I have on the board? We'll just go through one by one. Can I find this area? The area of the painting. Can I find that? Yeah, what would that one look like? Yeah, W times W plus 10 would give me the area of the painting. So I'm going to take the area of the painting out. I'm going to put W times W plus 10 in. Can I find the area of the frame all by itself? How would I do that? W plus 6 times W. Oh, I hit it too early. W plus 6. I'm going to back it up. These blue expressions would give me the whole area. So this one is when you multiply the red expressions. The whole thing is when you multiply the blue expressions. What am I going to put right here? 402. Look, it's in the directions. I don't have an expression to represent just the green. But that is the value that they gave me in the directions. So all of what we just talked about is going to make our equation that we have to solve. So once again, the area of the painting, the smaller rectangle, W times W plus 10, plus the green area, the area of the frame, which was given to me in the directions, will give me the area of the whole thing, which is W plus 6 times W plus 16. All right, here is the equation that we are going to solve. Now, there's a little more distributing going on. We have to distribute the W to a binomial this time. So W times W is W squared plus 10W plus 402 equals, we got some double distribute back here, W squared plus 16W plus 6W. What is 6 times 16?
36.
Okay. No like terms on the left, but I can add these guys. So W squared plus 10W plus 402 equals W squared plus 22W plus 96. All right. Then what?
Minus the 10W or minus.
I'm going to minus the W squareds first so I can just cross those out. Now, at the same time, we can get those W's together, so minus 10W from both sides. Those are gone. I have 402 equals 12W plus 26. No, 26, 96. Minus the 96. What is 402 minus 96? 306 equals 12W. Anyone?
I guess. I want to say 50 something. 0.5.
306 divided by 12. Anyone? 51 over 2.
It says 25.5.
So 25.5? I'm going to go with that. All right, 25.5, is this inches?
Yeah.
Okay.
So 25.5 inches.
So one of my dimensions, and I'm going to write it over here. This will be my answer. So I have 25.5 inches by, so that's the W. What did we call the other dimension of the original picture? What was it? W plus 10? So what is 25.5 plus 10? 35.5 inches. Now, I don't have the question right in front of me. Is that what they asked me for, the original dimensions of the picture?
It just says what are the dimensions of the painting.
Of the painting, right. So if it asked about the frame, you'd have to add 6 and add 6. But it's just asking for the original painting dimensions. So we're good.
That was interesting.
This is a fun problem. I like it. What are your questions? Now, is there a reason everyone went blank when the answer was a decimal?
We're not
don't have calculators, not confident. What's the problem?
I guess we just work new stuff.
A little of both. It's okay to get decimals. You will survive, okay? We have got to get through this so we can start some registration action. So, example 4. A rectangular picture is 3 centimeters longer than it is wide. The picture is surrounded by a frame, so same idea, that is 2 centimeters wide. The area of the picture and the area of the frame together is 100 square centimeters greater than the area of the picture. Whew. Find the width. So now we're just looking for the width. So let's go ahead, sort through all this mess. The rectangular picture is 3 centimeters longer than it is wide. So what can I call the dimensions of the picture? W and W plus 3. Perfect. Okay, now I'm going to put a frame around it. Boom. The picture is surrounded by a frame that is 2 centimeters wide. So if you add 2 centimeters in all directions, what are you adding to each of these dimensions? 2 and 2 makes 4. So the new width would be called what? The new width would be W plus 4. And the new length would be W plus 7, because you add 4, 2 and 2 to the 3. Good. Now, this is the tricky part. The picture is surrounded by a frame. The area of the picture and the frame together is 100 square centimeters greater than the area of the picture. So any ideas what I'm going to start with? Let's say I start with the area of the picture. How would I write the area of the picture? W times W plus 3, right? What would I do with that area to make the whole area? You'd add 100. So that's kind of my strategy here. I'm going to find the area of the picture. I'm going to add 100 to it. That's going to equal the area of the whole thing. Now you can replace these areas with the actual expressions that would represent the length times the width. So the area of the picture is W times W plus 3. The area of the whole thing is those two binomials, the W plus 7 and the W plus 4. All right, here's where I'm going to start. I am just going to fly through this one so we have a little time to get the work done that we need to get done. So this is going to be W squared plus 3W plus 100 equals, we got W squared, we got 7W, we've got 4W, we've got 28. All right. I have W squared plus 3W plus 100 equals W squared plus 11W plus 28. The W squareds are going to go away. I'm also going to subtract 3W. I have 100 equals 8W plus 28. What is 100 minus 28? And what is 72 divided by 8? 9. They are asking me for the width. I have found the width. We are in centimeter land. So 9 centimeters is our final answer here. Now, today we learned Area word problems. I'll put WP. All right, I'm going to give you your homework, and then I'm going to explain what your future in mathematics holds.